Okay, that's because the larger object usually get more details and more high frequency details. Okay, you can apply the same to smoke as well, like the steam coming from coffee cup versus like a volcano. Or here is like a hot spring steam. And then the great thing about Houdini is that you have the freedom to mix and match your tools. And for me, I always use socks to help me support and create my effects. And so a simple example on the left is something like a cigarette smoke. Right? So for cigarette smoke, instead of doing pyro simulation, it's very simple. We can do a pop sync with some noise. And we can create a DVD from it. And we can use the volume sharpen. We get some nice detail. Okay, so you can see that even the image is more dense and less dense. You can see where the detail are. Okay. Then the next one is a rain on right. Okay, so this is a rain particles only done in salts. Okay, there's no simulation there. So the idea behind it is very simple. You have a point moving in Y, so it's going downwards. Every time you reach the bottom of the bounding box, it will reset to go back to the top. Right, so just keep doing this moving motion. Okay, and the good thing about this is that this is very fast. Right, if you think about setup, we are not caching anything with this. So imagine you need to render 100 scenes with rain. You are not generating 100 with a cache, or even worse, 100 scenes are trying to read the same cache. Like all these are generated with render and it's very fast. Okay, so always think about what are the better ways that you can do stuff. It doesn't mean that with effects, we need to jump in and share the value of simulation. Okay, so now we have arrows hitting is sticking on the moving director, right? So this is easy as well. If you want to do it in a pop sim, you have to do a pop simulation, then you need to stick on object. It's not to get bubble when the character is moving in this way. So here is a simple solution. We scatter some points as the source. Okay, and then on the object, we project a ray. Okay, so this ray, what this ray does is that it's trying to see in this direction. These are the areas that will get hit, right? Because of it's moving forward and back to the region. And after that, we scatter the same amount of points to that. Then lastly, we just connect the 2 points together to create a line. Then we do some more magic to make it to curve. Then you can have a point within a curve. Right? So because the points are generated on the character, but the character is moving, the points will still stick to one. Yeah, so that same idea was applied for this simulation on the left. Right, so this is a shot from Jungle Cruise. So the bees are flying and landing on the character and crawling around him. Right, so in there, the final solution is quite simple. We have a pulley, just like the arrow, moving from the back to the front. Then we add some noise to the path, so that it bends the path. That's how the bee motion looks like this one. Okay, and then when we reach the character, we will make it beneath 1/3 of particle scene. And then 1/3 is just moving around the character. Okay, so that's how it goes from flying to landing, we call it. And on the right, yeah, we have these puddles and water splash, right? So in this one, we are not doing any heat simulation. Okay, so water doesn't mean that we need to do a heat sim. Here we are using the Reaper solver. Okay, so we're using the Reaper solver on the puddles. And then for the particles, we're just doing for the splash, we're doing a regular particle sim. And here we are doing some hot clumping to give it the shape. Okay, so to very simply describe this clumping, we have all the particles shooting out. Okay, and we use a point cloud to find it. Maybe every 100 particles, we have one particle, right? So we have some points in between. And then for all the surrounding particles, they will all move away from it. Okay, in that creates a global pattern. Then we can just multiply different versions of the difference to get more and more of a web pattern. Right? And if you increase the number of points, then make a smaller detail, you reduce, and you get a bigger detail. Okay, so all these are just effective way of getting the same result without going on main seed. Right? And the other thing I noticed is that usually if you don't do the actual simulation, right? All these things that we can perfectly results, you end up getting a better result. Right? That's because you are not running an actual sim and you want to really study it and see like how it should move and how I can recreate that motion. Okay? And because of that, you end up most of the time making the effects better. Yeah, and lastly for water is very interesting. There's a lot of different methods that you can work with, right? So I got view condition, using water level, now we have FMPN as well. And even at the bottom right, we could be a mesh with some writers on the water coming up. So you can think about all these solutions. I always try to find the cheapest solution first before you go and do a complex thing. Okay, next, here we are trying to create controls for setup before and after simulation. Okay, so the whole idea for this is that we want to avoid wasting time swimming, right? Because as you pick your control, every time you click it, you're simulate, and then you're wasting time, especially if the sim is taking a long time to run. Okay, so one example is this simulation of like rocks particles here. Okay, we want the bigger rocks to move lesser, like those that is been pinkish color. We want it to move lesser because they're heavier. And we want the smaller ones to shoot further because they're smaller. And if we do that, we usually give the mass of the particles to the PCA, right? So every time you want to change the PCA, I want to get what's bigger or smaller, the motion changes. Or every time you want to change the mass, then your PCA will get affected as well. Right? So that way your motion and the look are all kept together. Right? It creates a problem. Because every time you want to make a change, you are going to reiterate the session over and over again. Okay, so one easier way to achieve this. Okay, firstly, we created yep. So firstly, we set some velocity. Okay. Then we try to find the length of the velocity. Right. When you find the length of the velocity, you know how fast it is. And we use the reverse of that to make it to a scale. So meaning if the velocity is slow, we just leave it bigger scale. And this scale is bigger after the scale. And if the velocity is fast, then you just leave it a smaller scale. Okay, so that way you are separating your motion and your look. Okay, so anytime you want to change the look or overall you want all the rocks to be bigger, some to be smaller, you just think that without changing the scene. Then there are of course a lot more attributes that you can change post scene. Okay, color, you should know we can use edge to change the color. Right? One thing that a lot of artists will use is that you can change the life also. So if you're really unsure about the simulation, you can see it with a longer life. Maybe the life is 5, so it may be for very long. So after the scene, you give it a random life, then you can say delete if the age is 4 in life. Right? So that way you don't need to keep seeing to achieving the lifespan of the markers. Okay, then lastly is my favorite trick. So for this one, we are doing an exposure group. Okay, and we usually struggle with this because we look at the reference, the first group frame is small, and then after that it quickly becomes very big, then it stays the same way, right? So in order to achieve that, we put a lot of velocity, then we put a lot of drag, and the brute forces keep fighting with each other, and we can't really resolve that. So the final solution is actually very simple. We just see what regular exposure, then we take the first 2 frames of the cache and then elevate the scale to be smaller. Right? So that way you see at first when it's small, then it quickly become big. Right? Always not really at scene, just messing around with cache. Right? So we look at extra points to get everything correct in the scene. The meaning that we want to get is to get the results correct. If there is always results and control. Have to make sure you control you do have the control of the simulation. Okay. In effects, we always try to follow 80% rule, right? So what this means is that you spend 20% of your time to reach the 80% stage. Okay, so this 80% stage could be like the overall look and emotion is done, right? And then you spend the remaining 80% of your time to refine the last 20%. Okay, so let's talk about how we can use Houdini to do this. Okay, first, A lot of you should be familiar with this reusable tools. So in Houdini, as much as possible, we try to keep a procedural workflow. Right? So each node should perform a function based on the vehicle. And attributes should also be based on modification of target information. So this is non-sync and purely based on sorts. And it's also super fast. And it's meant to be used as a post effect, so you don't need to see with high resolution. So there are controls for you to adjust the vehicle size. And since this is all in sorts, you can gain very egress to apply if the vehicles when you possess a match. So on the right, we are applying the vehicle deformant in VFX simulation. So that will actually make more and more sorts available in Apex, and therefore you can use them in VFX simulation. So right now, as the animator is moving the characters, the written form is real time, and it's also very stable. So there's no simulation here. In this way, the animators can give a much nicer result in presenting the animation, and in some cases, this can also go straight for formula. And we also have improved our code image that is still in real time, but it's already at the workstation. Then we have our new information panel. So after customers giving us feedback that our UI is getting a bit outdated, this is what we come up with. We've added color coding to organize the information and to present them better. So two things that I want to point out. Firstly, we have toggles on the attribute that allows you to visualize the attribute in the viewport. That makes all the attributes of the toggle. And this has been around for a while, but nobody knows about it, so we're trying to make it more obvious to the toggle. And the next thing is that the information currently can exist in a locked pane, and that way we can access to it intent. So now it's more accessible to see and to visualize the attribute. We can now also create partial presets from words, and this is useful. So for example, if you have a HJ or digital asset for ring, with different settings like library, ring, thunderstorm, based on your different sequence environment. So these settings can be saved as a preset, and you can share it to other team members. On top of that, we can also create recipes. So recipes are a bunch of notes that is linked to your current work as a setup. Okay, so, and in fact, that is how we are setting up our example of files in 80.5. If you go to recipe, it will show you the example content. Right, so overall, these two features will help us to set up sticker and also make sharing with you. Okay, on the left, we have our standard weak capture and weak to stealing. And on the right, we have a machine learning definition. So what's nice about the result on the right is that there's volume preservation, right? And there's also no penetration since this is all trained in a software simulation. So now this brings us to the topic of AI. Right? In some effects, our focus is on machine learning and specifically to create tools for users to train their models. And Houdini procedure is able to create a huge amount of data easily, which makes it a perfect match for ML for machine learning. Okay, to give you a very simple example. Okay. So we have our input. Okay, to go through some complex processing like simulation, response processing, and then you have output. Right? So one example will be, let's say you're moving on games or animation, and you want to get vectors on direction of where the logo is going in the new. Again, we want to use that vector to push this knowledge working about universe to roughly something that means to on the way stylized animation. Okay, so there are many different levers in the object, and what makes it even more difficult is that we also have rocks in the river as well. So the water not only to flow along the river, it need to flow around the rocks. Okay, and every time you have a new river bank with rocks, you might really need to run a 200 frame simulation of 3 rows until you get to this point where you're going to have this. Okay? And what make it even worse is that if someone, before you keep changing the asset, then you keep making mischievous. Right? So with machine learning, what we actually do is to create an interface of input and output. Okay? So this input could be procedure, right? So within consider modeling, we can easily generate different river shapes, we can generate different box position, and we use that to run our result. Okay? So once you have all those inputs and result, you can use PDG to tune up the process and run it out. Okay, so this is why our machine learning tool comes in. Our machine learning tool will pair the input and output to type in or training. Okay, so after your training and model is done, the next time you give it a new input, the output will be generated immediately based on our skill model. Okay, so this is what we're looking to achieve by this stage of machine learning, and there are tools available in slots and ops or machine to help you with tagging, training, and live model covers. Also, I want to just mention that we have customers that use Houdini to generate a lot of synthetic data for AI companies to do machine learning. So one example is that they will do procedural streets or procedural buildings or self-driving factory. Right? So it's proven that Houdini is able to procedurally generate a lot of useful data. And now we are able to use that technology in Houdini to train the machine with a model specific units in this way very soon. Okay, so now that you understand a bit more about machine learning, we can go back to this example again. So the result on the left, the result on the right, the one we see the left definition. So this is live. Because all the shapes are generated from the machine learning training. Okay. And here we simplify it so the inputs are the joint rotation. Okay, so whenever the shoulder or the arm, the cover is rotating, we are taking that as the input. And the output that we are tagging is actually the delta or the difference between the skin object and the scene data. Right, so we just get the delta. So we know what's the difference does it need for which we go from this ugly looking skin version to the nice scene version. And that's what the machine learning model is doing. Whenever it detects the rotation up to a certain value, we'll try to generate the delta in 15. Right, so yeah, this is what we have right now for machine learning, and we are also sort of watching the industry and also based on customer feedback, how other customers are using machine learning, what is useful for them, and then in reality we'll start to progress more in making useful tools or trying to develop this processes.
Do you have questions that section? And that was a big topic that what do you want?
Okay, let's move on to reading updates. I'm very excited about how far reading really has progressed and the potential we're seeing. So we did introduce the Apex River, which is not really modular, but also very fast and interactive in this. Since animation is very new in Houdini, well, it's new to most people in Houdini, I just want to recap some of the basic with this before we start. So KitFX is our animation and reading toolset. We are able to create and animate at a job motion level in subs and in those space. So in KitFX, there's no bones or joint objects, but they are not a special class of objects. We are just using points. So points in space, the points will be joints. And if we look at this image here, which is pointing like sort of at the knee of the leg, right? The lines on the geometric tectonics that defines the hierarchy. So if the foot connects to the knee and the knee connects to the hip, that's how the parenting relationship works. And in Knee 20, we introduced the text graph for rig logic. So rig logic constraints systems of modes. So for example, things you are familiar with IK, FEA, Buket, and also their controllers. So the idea here is that you achieve that with your rig logic to build a rig, and it is much faster because the rig only evaluates any feature once everything is done. Then you don't get solved by multiple evaluation. And for educators, we only work in one word, which is C animator. So educators don't need to jump around to become able to try to find where are the controllers and stuff. So as compared to Houdini 20, we now have a long list of predefined authoring components to get you up and running faster. We can still create our own custom liquid logic to modify if we want to. So some new things I can then reverse to look at. And in fact, now in lecture, I will back up a little bit. We slowly created authoring capabilities. So that means you're now able to create your own rig with this as well. And at the bottom, we're just going to see how authoring logic is modular and building up to final. As we switch on each authoring node to turn on the controllers, you can see that the character is start to be able to move from the return on slide controller for the slide and reverse move for the flip. So what this is showing is that we can progressively add or remove rig logic controller and you can still work with and still enemy. Turning is much smarter now. So just now as we mentioned, points, the joints are all points, right? So in these points, we put in the array attribute. You need to tag them. Okay, so for example, the right shoulder can be IK. Okay, so note of the IK can be to run other attributes or other looks, but we should try to avoid hard coding as much as possible. And when you separate out the tools this way, it makes it very easy or you can troubleshoot because you can mute or remove certain nodes. Right? And all these nodes that we have here, you can really use them in the future for other setups. Okay, so for personal use, you can use especially tools like Valves or Wrangler. This can be stored in your tools gallery. Okay, so you just take from your network view and you just drag into your network, your tools gallery, and then this will always be saved there. These tools are saved under your user folder, the Linux version. Yeah, so as you change your Houdini version, remember to copy gallery file across. Okay, and when you use them, you can just drag and drop anytime. You can access them in your node. You can also make use of the toolbar if that's what you prefer. So here we drag and drop the bunch of nodes, and the toolbar button will be created for you automatically. And the next time we click it, you will get back your serial mode. And this can be saved on a network path or on a power block. And lastly, for record management, we can create HDA or Houdini visual assets. So this HDA can be packaged and distributed to other users. They also appear in the tab menu, so you can really create your own set of tools for your colleagues' use. And of course, not forgetting what was mentioned in the 30.5 presentation, we also have recipes and presets. So with all these ways to reuse your tools, we can work much faster and as much as possible avoid starting from scratch every time. If you have worked for 3-4 years already and you're always starting from scratch, you should start thinking about why are you always building from scratch? Why are you not creating tools that you can use and in use? They will rethink about your workflow. So to refine our effects, again, we need to run the same configure dance. And sometimes when you reach a certain stage, you really need to keep it in sync. So that's why you need to run the same configure dance. And this can complicated, especially if it's a multiple step process. Okay, for example, let's look at this split sieve. First, you need to cache the tolayer, which is a helicopter. Then you need to sim the flip particles. After that is done, you use the result to sim the airfield. And you also cache the fluid surface, which can also cache the white water source. Then we use the white water source to sim the white water. And then we render all the clusters together. And then we come for approval. Right? So every time you run the version, you need to redo all the steps. So luckily, we can chain them all up with PDG. Okay, so PDG is procedural dependency graph. It's there to help you to manage the sequence of the process and help you link them up to run them. Okay, so each dot is the equivalent to one process. In this case, it's equivalent to one page. And here we have a wait for all mode. When we have a wait for all mode, and what that does is that we make sure all the caches are not undone before we start singing. So for example, you need your water surface, you need your white water source, and you need your airfield to simulate your white water. So this wait for all is a publisher node to help you make sure that all these processes are done, then it runs the next process. Right? So this becomes a very, very bulletproof tool. The processes are being handled by you, and you can easily hit them to see the dependencies. Right? So these process is dependent on this, which is dependent on this rate, and so on and so forth. Okay, so now with this, and just use one button, we can basically resim or recache, resim, and render the code. Right? And imagine that you are working with animation and animation is always updating. You can just run it automatically install that. Okay, so I think This is very important, and as much as possible, try to work towards this procedural flow, where you can always have one button or one click to run the full day. For me, it's a good test as well. It means that if you can't run everything with one button, then your setup is not procedure. Because you need to go in and do some manual DB. And in KDG, we can use different scheduler to help you run processes on the farm or run them locally. So we have the database scheduler or the local schedulers. And on your local machine, you can use your extra cost to create your own mini render farm. Right, so we look at the right side, we are setting up these processes with 6 extra service. So they are open and now they're waiting for you. Anytime you cache something, all these services will run and have to cache in the right, so this is a thing of good use of spare resources. Okay, so now we go talk about how to treat scenes. And this is really dependent on how much you understand the solver. Okay, so for particle scene, it's quite straightforward. Particle scene will usually behave the same regardless of the number of particles. So if you are starting to treat the initial velocity, starting to treat gravity, always try to use a lower particle count. Either you're happy with it, then you increase the particle count. But SOUs will always sing at 1 year points, and then you delete and then you remove and you sing. Then the next thing is Velen. So for curve-wise, Velen has improved a lot in the last version. So this is no longer resolution event. Previously, what we noticed is that when the resolution is low, you start to get more sluggish motion. And the resolution is high, you start to get more detail and a different speed and different shapes. Okay, so now it's no longer the case. So your Velen, you can still reduce the amount of the mesh, you can still get very good result or get a good preview of the result. We need just to make sure that you have enough resolution so your cloth can still bend and fold to make it clearest. And also remember, if it's 20.5, we have the wrinkle deformer. So you no longer need to seal and survivors, right? It can be a mid-press, they will seal, then you go through a wrinkle deformer. So for pyro, surprisingly, pyro, the motion and the scale looks quite similar between high-res and low-res. The only difference is the look because of the pyro scatter shader looking at the resolution. Okay, so as much as possible, maybe you get your motion and scale binding working first. Then when you go to your high-res scene, then you tweak your pyro scatter. And for lastly, for flip scene is quite tricky. Because when you change the particle separation, the fluid tends to move slower and be a lot more viscous if it's a low resting. And so in this case, when you want to have a preview of the final result, what we'll do is that we just take a small box, right, a small box, and really sink within that box. So that way you can get your final scene resolution, but only at the limited area. And this will run super fast, and you can check for collision and how the water flow down against the layout. Okay, so there's different ways of getting and then getting the result back. So sometimes, actually most of the times, artists forget that they are on one circuit for picking, and then when you want to do high res, they switch back, right? So you can always put in a switch mode to switch between the low res and high res settings. That makes it easier for you to work. If you are familiar with like a pre-scene script, you can use the script to toggle the switch, right? So randomly when you're going for final, you run it, then you will switch to the high res. Okay, so now we have this case where we have a few different settings that we want to balance. And this is where PDG version is very useful. Here we have 3 different settings for we and 3 different settings for release business. Sorry, for first business. Okay, so we have 3 settings for we, 3 for fur. And based on these 3 different settings, it's able to get the different combinations to get the 9 different versions. And in PDG, you can even see Game Glass and play this spreadsheet you see here with all the scene settings printed on top. Right, it's really useful. So previously, I always have a notebook because I couldn't run the spellings working to and then write out all the settings to receive. Now in here, they can get the results. and you can immediately see the service actions. So you can submit this to client or service to a supervisor. Once they approve, you can use the CV shift. Okay, so one final tip to speed this up, we should always try to reduce data filtering. Okay, a lot of sync and caching is slow. It's because of the writing to this and also reading to this and also network conversion. Okay, so one more practice is before you save anything to this, just delete everything outside the network function. Okay, that will save you a lot of work. And also take note of the attributes you have to keep. Okay, you don't need what you need. Right, so here we use attribute delete and we delete a bunch of default attributes that's starting with all. So like ship power, ship looker, and we see about size sorting. Okay, so if you have a reduced file size, you use less displays. There's less keyboard, you can text easily. You only need to enter the text to loop form, and the auto-read component will set up all the bonus map. So I can have one IK auto-read component node to set up IK for both arms and both legs, and to set up the IK target to so that makes your workflow much easier and much smoother. Here we have an example where we have 4 completely different characters with different body structure. Like some have tail, some have a trunk, some are 4-legged, some are 2-legged. But if we think about it, we have structures that are same as well. So for example, all characters have legs, which are tagged in green there, and all the arms are tagged in red, and the spine is tagged in different color, and feet is tagged in blue. So now we look at this red select. We are using the same auto-read component. Okay? The only difference is that we are switching between characters. Right? So the big logic is all the same. We are using the same words, and we are just switching between different characters. The other big difference is that we have a subnet of tagging. So, for example, the elephant will have 4 legs tagged for reverse foot, while a human model only have 2 legs tagged for reverse foot. The other thing I also want to bring our attention to is how fast the read is performing. So you can see as we switch between characters, but this is real time by the way, there's some phone lagging. So other characters, we can also read other objects like this are still engine. So for the wheel, when we are using a loopback constraint, okay. For things like the piston, the piston is doing some very unique motion with specific limitation. So for that, that's when we need to create a custom read logic or custom device runner. So based on feedback, we understand that users are familiar with and also prefer to use Python instead of using a node-based workflow. So now we have Apex Suite, which is an Python-like function that create and also link Apex nodes. So here are 30 words of Apex Suite and it creates 59 nodes. Okay, so that just says that we don't need to go in and create the nodes and wire and stuff. Just to bring back some basic again, Apex is different from VOPs. So in VOPs, the VOP nodes get turned into vex script and those get delivered. But in Apex, the Apex script turned into the Apex node. The Apex one is of read, and that is why it's very good value in the end. Here we're looking at a procedural solution for aggregating with spider legs. The run that we're seeing is the animation curve of the legs. So with a script snippet, we try to apply different parts of animation to each leg. So now if you turn it off, it's called moving. And since this solution is procedural, you can use the same setup for 4 legs, and it will still work because these are all separately different. And the IK with control, and just still work even if the work is better. So to effectively showcase our animation, we want to present as close as possible to the environment data. So achieving this for fur and feathers is really very difficult. It involves animation and something with visual effects. Visual effects is for the lighting and some of it doesn't do anything like that. So now we have an room mode, and animators can visualize the room with source information. It is definitely useful for animators to see the silhouette and the volume of the characters when they are posing and making awareness. So on top of visualizing the room, we can also control and animate the room. So now we select some feathers, and those characters will be back controls. So you can see how the removing is deforming the feathers in those 2D. So say here, where with mohawk hair. So the great thing about these animated fibers of hair is that they actually deform easily. So we can use it down the pipe for final render or use it to drive simulation for feature effects. And that way there's no wasted work or double work for feature effects to reproduce the same thing. So guide controls can also be created procedurally, and we can also define the influence of these guides. So animators can now add this in areas where needed without having to go back to view. And if you remember, the auto components are modular, so you can go and add in these controls in memory. On the right, you are seeing the mid post band or more precise controller, namely your forward wheel position. So the data trading system has shown huge improvement in release, and it holds very good rate attention for it to be a procedural reading preset. However, we still need animators to get it to Houdini editing rate, so we can move on to animation.
Well, Alan's on it to show it possible. Were there any questions about the Apex reading functions, difference between Apex and Apex? Moscow? No, that. That now. Who in the room currently uses an animator? If anyone. Raise your hand. You up. Cool. What do you think about what you just bought?
Actually, let's say measurable market. So probably we use Maya to believe it. But if could make try to it in really as well.
Maybe. You also make section.
Now let's move on to animation. So as I mentioned before, the Apex, KineFX Apex system is created with animators in mind. So firstly, the ease of use. They only need to animate in the scene and view mode with the controls or in the board. And secondly, the speed. The rate animation is delayed. So when you interact with the rate, it's extremely fast. And that being said, we're also focusing a lot on quality of life tools for daily business. First up, we have animation video on the left. So this is a very popular request from customers. The layers can either override or be additive to other areas. We can also adjust the rate of the layer and also further map the combined layers. So this controls will make it easier for animators to test out the different mergers or calculation of layers. Here we have the copy and paste post feature. We copy the post from the head, and we go to the barbell to paste it. We now will put the barbell to be where the head is. We can also set up any controller to be the pivot of the game by holding the Control Shift hotkey. So now we hold it and when we move or rotate the head, you can see the barbell is following along without doing any parallel motion. There's also a label mirror post tool with a preview. So you can see the different options available before you commit the move. And now with motion path, we can see the spacing and arcs of animation. So here with the line, each cave represents a single frame. We can also interact directly with the motion path between the animation bed, so that makes it easy for you to visualize and execute. Now we're also showing controls to limit the number of frames. We show the motion path if you want to concentrate on the frame range or if you have a lot of overlapping paths in the motion. On the right is transit constraint or time constraint. So now we are attempting to constrain the ball with hand when it's very hot. The constraint is visualized on your hand line at the start with an orange movement. In our condition, it is faster on far to right refresh and it's faster to read the how to weather. So integer is the cheapest or by float. So if you have a mask, for example, that can float instead of a color. Or if you have an ID, that should be an integer instead of a float. So some attributes can be converted into detailed attributes. If it's just a constant value of whole geometry, there's no need to state that attribute for every single one. And then lastly, we can also attribute cast to reduce the precision. Okay, so reducing the precision to 60 give me some data. But take note of this, try not to do it on position. Because if you reduce your position on position attribute, your pose will start to jitter. It is very far from the origin. Whereas person is going far is trying to make sure that it have enough position to track over the frames. So yeah, overall be conscious of this usage. And try to use that storage infrastructure as you can. And lastly, the interaction. So for an effect to be deliverable, you have to think about how it exists in space. Okay, so you think about how you're sitting on the chair now. Are you casting shadow on the chair? Does your chair make a wrinkle because of the compression? And is the chair casting shadows on the feet? And is the back of the chair casting making a sharp wrinkle? Okay, so when you add something to the environment, it's not just putting something there. It will make the space more different. Let's look at one of the book. So like sparks will light up the environment. The rays there are reflecting in the water. And the exposure will displace the dust. And lastly, you feed will leave footprint and also push up the sand. So anytime we have a chance to show direction, we should add it in. But here is a simple example where we sample the character's velocity. Then we use that as the pulse on the because. And this can be an ash or snow, and you can show the character pushing through it. And in Houdini 30, we have a wind shadow. So this takes it a step further. The collision object actually blocks the wind, and giving more presence to the character. Now on lighting interaction. It's a good practice to have a task with all the objects, all put in and render together. Okay, when you render all the objects together, that's where you can observe the direction. So for example, the fire is lighting on the ground, the fire is lighting on the character, the smoke is shadowing the ground, the character is shadowing the smoke, and the fire is standing on the smoke. Right? So if you don't have a task like that, and just after creating a fire scene, you just render the standard smoke, fire, shadow pass, and that's it. Then the composer doesn't have enough information to work with, and they can't really get a good result. So from there, you know what the final image looks like, and you can break it into different DLPs for compositing. And now in 20.5, of course, we have a cost available or set count, so you can really check the work for each volume list before you pass it out to compositors. Alright, you come to the end of this one. And you can see if there's any questions.
So comprehensive, I don't know if you want to see the question. Anyone?
Yeah. Yeah, I have a question on the curves. I'm not really quite sure if it's really that systems designer or systems better. Right now it's only working Scala, right? Curves.
Codes. No, codes. So for codes, you can generate, you can save out the dash here as well. So you use the dash layer.
Maybe it's running it as an image to
Yes, run this image. If not, if I using it directly, then it's in viewport or found.
Awesome. Okay. Doesn't mean all let's install.
Okay. So I'll start first. Yeah, so we talked a lot about effects. Or at least I thought about smart effects really. And as mentioned before, Houdini is based also on the effect simulation. You can do a lot more than that. So in this session, we're not trying to explore the different tools available in Houdini and the different products available to give you the best value. So effects, yeah, all these are quite famous already. We have viral, bullet, flip, balloon for effects. Creature effects, we now have hair and the fur, and also the skin and muscle simulation. And we also have a lot really characters as well. So on the effects part, we have a lot of tools available. But beyond effects, we also have other systems to do to produce what you want. Firstly, assets. So for modeling, we have hard field quartering. That's very diversity. That's very much in use for our customer. And model tools for clouds. We have procedural modeling as well. And for texture, we have COPS that does the texture synthesis. And lastly, for look depth, we have a full suite of tools to do feather and fur ruling. For it, we also have material X and canvases. So we have a lot of strong tools that will help you get to the P1. And next for character, a lot of this was shown in the view config level. So key effects for reading and navigation, like by Apex. And at order, it is also key effects. This is before we have Apex, so all these tools are still available. They are used to do motion editing and also do motion transfer, where transfer within 2 weeks. And also motion leveling. For example, on the bottom right, there's someone running in the motion one. The kicking, you can combine those. Okay, so those tools are great for the work with vocab data. And of the rendering and we have very intuitive printing tools like Light Mixer and Light Inker. And our render gallery is really able to edit snapshot and revert in a frequency. We also have reduced memory usage with a HASC procedure, as I mentioned just now, for fur, for feather, for clouds. And of course, we have our Kala SQ and CPU, which are constantly improving. And lastly, new in 20.5, the COPS that can do that console. So other than that, we also have PDG. I think I mentioned PDG in a few different usage already. We can do measures, you can link process together. You can learn new things that are not in Houdini. So there are like Python nodes and short-tree nodes that help you run processes for other software. Okay? And then we have the Sound Effects Labs team. Right? Our team is there to help create our tools to make your workflow easier. Right now, a lot of the target is in the game socket. That's because they are mostly dealing with the games customer. Of course, the tools they created are available for everyone to use. And also for the labs team, the Sound Effects Labs tools, they are not linked to the Houdini development cycle. Right? So what that means is that every now and then, the labs tools will get updated. If you go in and download and install, it doesn't update with every Houdini version, like 30.5. So they're all quite up to date and very useful. And lastly, we have our machine learning tools installed and defaults.
Oh, that sounds very good. You should give our resource a rest. Thanks. It's very not good. All right, so in my role as side effects, I work directly with studios, and a lot of the questions we talked about sometimes come from functionality, but a lot of the time can be really maybe a little bit more basic stuff that relates to how I run licenses, how I find users, how I purchase licenses, what infrastructure should I be using? Because it's sort of day-to-day questions that we get asked a lot. So I sort of spend 20 minutes here just going through that and making sure it's something that we communicate information off. So picking the right product for the task. So it's not that big that often people aren't aware, and this is simple, but often people aren't aware that multiple types of Houdini licenses is at different price points that are specialized for different tasks. So in this first section, we're going to talk about picking the right product, Houdini effects, Houdini core, or Houdini engine and render. So in this first breakdown, we're looking at interactive licenses, specifically Houdini effects and Houdini core. And so what is an interactive license? It's simply a type of license with its GUI or GUI that you use and interact with in Viewport. And as you can see here, both the text and core will give you access to a wide array of functionality. You can use core for modeling, character, terrains, environments, lighting, layout, and purpose layers. Plus, both around new context effects take advantages of available in Houdini core and get a very powerful license type. So where much you need an effects license. So simply you will need an effects license when you need effects type functions on the